Good morning, Morgan, and good morning to the second of 3 boring only reading videos. But this one's going to be a very short one. That said, the next one is going to be a long one. It has to do with organizing the information. I know I'll be honest, what I'm doing is I'm actually just following the tutorial of Python, the people that made the language. And this is the way they subdivided the data, the information, so that's why I'm doing this. And with that said, let's get this reading out of the way so we can all go and do something more entertaining.
Python TV57. A word about names and objects. Objects have individuality, and multiple names, in multiple scopes, can be bound to the same object. This is known as aliasing in other languages. This is usually not appreciated on a first glance at Python, and can be safely ignored when dealing with immutable basic types, numbers, strings, tuples. However, aliasing has a possibly surprising effect on the semantics of Python code involving mutable objects such as lists, dictionaries, and most other types. This is usually used to the benefit of the program, since aliases behave like pointers in some respects. For example, passing an object is cheap since only a pointer is passed by the implementation, and if a function modifies an object passed as an argument, the caller will see the change. This eliminates the need for two different argument passing mechanisms as in Pascal.
Okay. Now, you're probably a little confused, as am I, about what they were talking about. Specifically, when they started talking about pointers, okay? Because when they start talking about pointers, they're talking about the internal workings of the machine language that as a programmer, you need to be aware of it, but you really don't need to understand how it works. And let me explain to you what a pointer really is, because apparently they don't know what it is. Because they certainly didn't do a very good job of describing it. A pointer is an address, just like there's an address to your house. It's a location in memory, in the machine. Okay? And you need these pointers so that the CPU knows where to go to get its information. Okay? So and by the way, there's like millions of these transactions going on per second in your computer. Okay? So when the computer needs some information, okay, it goes to the pointer, and the pointer will tell it where it is and how big the file is. Okay? How to visualize this. Imagine a line of dominoes all lined up ready to fall over that just goes off into infinity. Okay? What the pointer does is says, go to the 5,627th domino. A domino being a bit of information, a 1 or a 0. And starting there, grab the next 5,000 dominoes and put that in the register in the CPU, because we're going to need that to do a mathematical process on. That's a pointer, okay? And what they're describing here in this paragraph is how this language is developed so that it minimizes the amount of time the CPU spends with working with these pointers, because it's a lot of I/O. It's a lot of fetching and carrying back. And anytime you can eliminate a couple of those moves, it makes everything run faster and cleaner. Okay, you don't need as much, you don't need as much energy. You don't need as much memory. You get the picture. You're all very smart, spongy kids. Anyway, I hope that helped clear up what a pointer is. I wish that this text was a little more clearer. It's not. But it is what it is. And believe me, as you progress through your life cycle and your careers, you're going to see a lot worse than this. Sorry. And with that, why don't you guys go out, have some fun, try not to get stung by any bees, and we'll see you in the next video.